Welcome to Study Loop.
This is the answer to Chapter 21, problem number 62 from the Smith Organic Chemistry textbook. And this problem asks us to construct three molecules, and we're given some constraints around their construction. So we're told, so each of the molecules we're asked to construct is an alkene. We're told that the alkene itself needs to be constructed by using a Wittig reaction. And we're also told we can only use benzene and organic alcohols having 4 or fewer carbons as our starting materials. So basically, we're going to have to make everything that we need from butanol or less and benzene. So for A, we can okay, well, so since we're told that we need to use a Wittig to construct the alkene in each instance, we should know that we're going to have to make the Wittig reagent, and we're going to have to make the carbonyl compound that the Wittig is going to react with. So for each of these, we're going to essentially just make two pieces and then connect those two pieces at the alkene via a Wittig. A Wittig. And so what we're trying to make for A looks like this. And so we're going to disconnect at this double bond. And so then we need to make the pieces to the left and to the right of the double bond. And so we have 4 carbons to the left of the double bond. 1, 2, 3, 4. So we can start with butanol to make that portion, the left portion. And we can, so you could really do this, several different ways. So what I'm going to do is I'm going to make the left part my carbonyl part. So we'll take butanol, we'll oxidize it up with PCC, and that's going to give us this aldehyde here. And then, so obviously our right part needs to be made into the Wittig. So there's 2 carbons over there. So we'll start with ethanol. And then remember, the way that the book promotes making Wittigs is reaction of an alkyl halide with triphenylphosphine, followed by treatment with butyl lithium. And so we need to get ethanol here to the alkyl halide and then do that sequence. And so PBr3 will replace our alcohol with a bromine. And so after treatment with PBr3, we're there. And then, as I said, we can do the Wittig series to form a Wittig, and we can actually save some space and just draw these as a single 2-step process. So triphenylphosphine and then butyl lithium will get us to our Wittig here. Yeah, it's probably better to visualize it like this. PH3P double bound to a CH, CH3. And so there's our Wittig. And then we can combine the Wittig that we just made with the aldehyde that we made above. So there's our aldehyde. And that is going to get us to our final product. And of course, we would get a mixture of E and Z at this double bond. But the problem also doesn't specify whether we want one or the other. So this is fine. Right, so there's our product. And so that's the answer to part A. So then B and C are going to follow exactly the same format, where we can just deconstruct these molecules, essentially cut them across the double bond, and then make a carbonyl from one side and Wittig from the other side, and then just do the Wittig reaction. So, so when we look at B, I'll go ahead and draw the product again. So our desired product is going to be C6H5 CH double bond, and then another 4-carbon chain. And so to make this 4-carbon chain, right, we already know how to do that because we did it here in A. It's the very first thing that we did in A, butanol treated with PCC. And so we'll invoke that again later in the problem. So we just need to worry about making the actual Wittig reagent out of the left part. And again, just for ease of visualization, so we'll cut the molecule there. So the right part we already know how to make, and the left part we will make like this. So the problem tells us we can start from benzene, and so we shall. So we'll do a Friedel Crafts. So that's going to methylate the benzene. And then if we treat that product with bromine and light, we'll get benzylic bromination, so bromination at the benzylic position. So that's what that's going to look like. And then from there, we can make our Wittig. So again, just as in part A, triphenylphosphine followed by butyl lithium is going to give us the Wittig, a benzyl Wittig. So if we then use, as I said, we made in part A, we made this aldehyde, and so we can use it again. We would make it exactly the same way as we made it in part A. So I'll just write from A here. But that gives us what we need. Oops. C6H5 CH double bond CH CH2 CH2 CH3. So there's our final product. Okay, and then rather than try to crowd C on, I'll give C its own page as well. So again, we're just going to do exactly what we've done so far. So the product that we're asked to make in C looks like this. We should think about deconstructing it across this double bond, and then making the two pieces that we're going to need. And so remember, we have to start from alcohols or benzene. Obviously, we're not going to use benzene here. So we can start from isopropanol and just oxidize that up with PCC to get acetone. Okay, and that's going to be the left portion of our molecule. And so to make the right portion of our molecule, we'll start from this alcohol. And we'll follow a pretty similar sequence to what we did in part A. So PBr3 is going to take us to the bromide. And then from there, we can make our Wittig. Oops. Triphenylphosphine and butyllithium. It's going to get us to our Wittig here. And then if we take that and combined it with the acetone that we made above, that's going to get us to our desired product. Okay, and so that's the answer to C. And so the way to really approach these is to think about cutting across the double bond, and then look at the two pieces that you have, and think about ways to construct a carbonyl compound for one piece and the Wittig reagent for the other piece, and then just to do so. And so that is the answer to chapter 21, problem number 62.